Good morning, student. So, in today's class, we are going to study a very important topic from application of derivative, that is maxima and minima. Our today's topic is maximum and minimum. So before I start today's topic, I just want to revise you all what does it actually mean. Okay. So this ratio dy over dx simply means the rate by which the quantity y changes when there is change in quantity. Okay. So dy over dx is what? It is the rate of change of y with respect to x. Now, what is the geometrical meaning of this term? It represents what? It represents slope of a curve at given point. And what is the slope? Slope is nothing but the tan, right? And here what? Theta we measure from which direction? Theta we measure from anti-clockwise direction. Anti-clockwise. Now, let's suppose I'm going to x axis, this y axis. Suppose slope is something like this. Then what I will do? Theta will be always less than 90 degree, between 0 and 90 degree. So in this case, slope of this line will be what? Positive. And suppose our slope line is something like this, then in anti-clockwise, if we measure theta, it will be what? It will be greater than 90 degree. In this case, slope of this line will be negative, right? So you know this basic thing. You know about dy over dx. Okay. Now let's plot it down. Now student, today we are going to study the maxima and minima. In this topic, we will try to find the maximum minimum value of the attained in the given interval. That is the basic idea of maximum and minimum. So, before I go ahead, I just want to use some terminology of the related to this topic, maximum and minimum. So let me draw the graph. Okay. So let's define a function y is equal to fx, where x belongs to, let's say, interval a to b. Now let's draw a rough graph of this function. Let's say it goes something like this. This is point, this is fx, this is y axis. Origin, here point A, point B. Okay. Now, what you observe in this graph? If you observe this graph, there are certain points where graph attains maximum value, and there are certain points where graph attains minimum value. Okay. So, let's see here. At this point, let's name it this x1, let's say this is x2, let's say this is x3, and this is x4. So at point x1 and x3, graph is attaining in maximum value in its neighborhood. Similarly, at point x3, graph is attaining a maximum value in its neighborhood. Similarly, at point x2 and x4, graph is attaining minimum value at its neighborhood, right? So the first term we have is local minimum. Local minimum is point x is equal to c is called local minimum if f c is less than fx for some value of hs and x belongs to interval c minus x and c plus x. Obviously, x will be not c. Okay. So don't get scared by seeing all these. It is very simple to retain it. Let's see point C. Okay. So we are talking about local minimum. So where maximum is where graph is attaining maximum value, minimum is where graph is attaining minimum value. So we are here the term local minimum. Okay. So let's say x2 is equal to c. We name the point x2 as. Now see, in the neighborhood of c, let's say this is okay. This c minus x and this is c plus x. So in the neighborhood of point C, the graph attaining what minimum value at what point C. Okay, and where we are getting minimum value at point C. Right? Let's say this is f C. So all other value of function in the neighborhood of C is greater than f. You can clearly observe. So the point where the graph our function attains minimum value in its neighborhood, we call it local minimum, right? Similarly, if we find another term that is local maximum. Similarly, local maximum will be what? The value of x for which graph attains maximum value in its neighborhood, then we will call it local maximum. Okay, so next one is local maximum. So point x is called local maximum. Local maximum. If there it will be greater than. So let's say this time. Okay. So let's say point x1 is 1 c in the neighborhood. So you can clearly see in the neighborhood of point c, the value of the function at point c is maximum in its neighborhood. Right? So point c graph is having maximum value, and any other point in the neighborhood of x, it is always less than f. So we can say that the point C is what? Local maximum. This is point of local maximum. Similarly, this point is local minimum. What we call this point? This is x3. What? x3 is the point of local maximum. Similarly, x4 is point of local minimum. You understand it? I hope you have clearly the concept of local maximum and local minimum. Now, you see, there are two local minima and there are two local maximum. So, out of all these local minima, the value of the function at which the point is lowest, we call it point of local minimum. Okay, so see what I am trying to say. So we have two local minimum. One is x2 and this is x4. Okay. So just observe the graph and tell me at what point the function is attaining the lowest value. It is x2 or x4. So you can see clearly at x4 graph is attaining the lowest value. So out of all local minimum, the graph is attaining the lowest value at x4. So we call x4 as point of local minimum. Okay. Or although it is local, we call it local minimum. This is also local minimum. But out of local minimum, the value of x for the graph is the lowest value. We call it point of local minimum. So the local minimum where function at lowest value we call it point of local minimum. Okay, we call it point of local minimum. And value of the function, correspond to this value, this value is minimum value of function. Minimum value. So you can clearly observe that if both the our local minimum, point of local minimum, obviously the value of the function will be the lowest at this point. So local minimum where our function attains the lowest value, we call it local minimum, and the value corresponding to it is the lowest value of the function in its domain, so we call it the minimum value of local term. Now, similarly, students, local maximum where function attains the maximum value, we call it point of local maximum, and the value corresponding to value function corresponding to point of local maximum is the maximum value of the function. Okay. So, okay, let's see where it is completed. So, now we have another term that is local maximum where function attains maximum value we call it point of local maximum. We call it point of local maximum, and value of the function correspond to this value is maximum value of function. Maximum value of function. Okay. So what does it mean? That out of all the local maximum, we have two maximum local maximum. This one is x1 and this. So out of all the local maximum, the value of the function where it is highest or maximum, we call it point of local maximum. Here it is out of 4 and x3, and for x1 the function is attaining the maximum value, so we call x1 as the point of local maximum and the value of the function corresponding to this value, we call it maximum value of the function. Okay. So also note it down. Now, student, I think you are not familiar with the term local maximum. Okay, in a function there can be many local minimum, and out of local maximum, the point where function attains the maximum value, we call it point of local maximum, and out of all local minimum, the function where attain the lowest value is called it point of local minimum. So I hope you are clear with this terminology. Okay. Now let's see, student. Okay, so now we will approach this graphical graph slope way, right? Slope of view. What actually happening with the slope? Okay. So okay, now we will come. See here, whenever there is a point of maximum, the graph will seem like something like this, right? Graph will something like this, right? So here let's see what is the slope of this part. This is what is the slope, okay? Right. Okay. In case of local maximum, our graph like something like this, right? So in this case, can you tell me what is the slope of this part of the graph? Right. This is literal. Here we should draw the slope line. It will be something like this. Okay. Here slope is positive. Okay. Slope is nothing but derivative of the function. So here the slope is positive. And what is the slope on this side of the graph? Clearly it is what? F is less than 0, right? And here point of this point will be 0, right? Direct it will be the our slope line will be the parallel to the x-axis. The slope will be 0, right? In case of local minima, you see the graph always similar something like this. Okay? So how this what is the slope of this part of the graph? It is always less than 0. And what is the slope of this part of the graph? It is right? And here it will be when it is parallel to the x-axis, it will be right. So now, and this point where the slope of the graph is 0, right? We call it what? Extreme point. Okay, so we just note it down. Extreme point. Okay. Extreme point, or we also sometimes call it critical point. Critical point. Okay. Where what? Where? The derivative function is 0. That is no the line is parallel to the x-axis. Then we call it as critical point of extreme. Okay. You already know this, but just let it clear what is happening. So in case of local maximum, the slope is first it is positive, then 0, then it gradually becomes negative. Similarly, in case of local minimum, the slope is negative, then 0, again it is positive. Okay. So based on this concept, we have first first test of derivative. Okay. And now we will study our next topic, that is the first test of derivative. Okay. So note it down. Okay. So let us so now you understand in maximum case slope goes from positive to negative. In case of minimum, slope goes from negative to positive. First derivative test. First derivative test. Okay. So first derivative test says y passing through, let's say x is equal to c from left to right. Okay, from left to right, left to right. I'm writing it in our own language in book there. Then we have another language, but the concept is same. Right? So while passing through a point C from left to right, we flow changes from positive to negative, right? Positive to negative, then point x is equal to c is what? From positive to negative, right? So first the slope is positive and then it is negative. So clearly this is what? Point of local maximum, right? So while passing through point C from left to right, if the slope of graph changes from positive to negative, this is positive and this is negative, then point x is equal to c is called what? Is local. This is local. I hope you understand. Okay. The first derivative test, the first point is while crossing a point C from left to right, the slope of the curve changes from positive to negative, then point C is what? Local. Right? Okay, write it down. Now similarly, student, while passing through point C from left to right, if the slope changes from negative to positive, then what will be the point will be what? Correct. This will be local minimum. Okay. So just I'm changing. This is from negative positive, then the point x is called local minimum. You want the graph something like it is changing from negative, right? So it is changing from negative to positive. So it will be positive. So it will be point of what? Local minimum. I hope you understand this concept. Now, the third point of this is if sign does not, okay, sign of slope does not change, right? Does not change. Then x is equal to c. If suppose we are passing through point C and this line of the slope doesn't change, then in such case the point C is called point of, then is x is equal to c is point of inflection. We call it point of inflection. Okay. We call it point of. So this is the third point of third derivative. So what is the third derivative test? Third derivative test says y passing through a point in x-axis, and if the slope of the graph changes from positive to negative, then the point will be local maximum. And if it changes from slope of the graph changes from negative to positive, then it will be the local minimum. If there is no sign change, then we call it point of inflection. Okay, so let's see a quick example of point of inflection. Okay, so before that, note it down. So, so point of inflection is a point where while passing through a point, if no sign changes, then we call it point of inflection. Let's suppose y is equal to x cube. Okay. So graph of this something look like. So here also the slope of okay. So at point x is equal to 0 at origin. So before origin also the slope of the graph is positive, and after origin the slope of graph is also positive. So in this case, while passing through the point O, the slope of side of slope of graph does not change. In such case, we can say that x is equal to 0 is what? Point of inflection. Point of inflection. Okay. So I hope you now you already understand what third derivative is. Okay. So based on this, we will now solve the problem and try to understand more better, right? And getting it. So let's say question real question. Fx is equal to q minus 3x plus 4, right? So we are given a function. Now we have to find local maximum and local minimum. Okay. And based on this, we will also find what? We will what is this local maxima, local minima, local maximum, maximum value of function, maximum value of function. Okay, so ignore the sound in background. So maximum value of the function, minimum value of function. Okay, so we try it. Okay, so now what is the f dash x? It will be what? 3x square minus 3, right? Is correct? So this will be x square minus 3. So now suppose I write f dash x is equal to 0, right? So it will be like 3x square minus 3 will be 0. So we will have plus 1 minus 1 will be 0, and we will get x is equal to plus 1 minus 1. What is this point is? Here, this will be particularly the slope of the curve, and we are equating it to 0. So remember, when slope becomes 0 at the critical point, right? So when it is critical point, slope of graph is what? 0, right? So let's parallelly try to draw the graph of so we find 2 points. One is x is equal to plus 1 and okay, so this minus 1 and this is plus 1. Okay. But these are the critical points. We have no idea whether it is point of maxima or point of minima, whether it is point of maxima or minima, right? So we have no idea, right? So how will we can calculate it? Okay. So now let's try to find the value of this derivative a point before minus 1, right? So let's check the sign. It is represented in the slope. So we are just taking the sign of slope before the point minus 1. At minus 1 it will become what? 3 minus 2 is y minus 3. So it will come down to what? It is 4, 4 into 3 is 12, 12 minus 3 is 9. So this is what? This is positive greater than. Okay. So, and after 1 it is, let's say 1 over 1, so let's say 0, right? It will become minus 3, it will be less than 0. So we see that at point x equal to minus 1, the sign of fx is before 1 it is positive and after 1 it is negative, right? So student, now tell me in what case the sign changes from positive to negative. Correct, right? This sign changes from positive to negative only in case of point of local maximum. So from this observation we can clearly say that minus 1 is what? Point of local maximum, right? Clearly check for the point minus 1. Okay. So before minus 1 we have the sign of the function is what? Less than 0. Okay. Now let's check for number greater than 1. Let's say sign of the function at 2. So we will do what? 3 2x square. It will be again what? It will be positive, right? It will be 4, it will be 3, it will be 9, that will be positive. So after 1, the sign of note is what? Positive, right? So now only when changes from negative to positive, it changes when in case of what? Local minimum. So we can from this observation we can conclude that point 1 is point of what? Point x is equal to minus 1 is what? Point of local maximum and x is equal to 1 is what? Point of local minimum. I hope you get it. Now how will, so we now get the point of local maximum, that is x is equal to minus 1 and local minimum, that is x is equal to 1. Now how will we find the maximum value of the function and minimum value of the function? It's very easy. Just put the value of local maxima in the function, we will get the maximum value of the function, and put x is equal to 1 in the function, we will get the maximum value of the function. Okay? So maximum, okay? So maximum value of function will be what? It will be f is equal to f what? Minus, right? So it becomes to minus 3x plus 4, right? So it is minus 1. If you get it also minus 1, so 3 equals to minus 1 plus 4, so it becomes minus 1, 4, and that is what? Okay, so the maximum value of the function, local maximum, that is x is equal to minus 1, it is what? We have obtained 7. Now let's find minimum value of the function. Minimum value of function. Okay. So it is f is equal to 1. Okay. So see, at f is equal to 1, we have local minimum. So we get to the value of x is the function. So we will have minimum value of the function. So that is 1 2 minus 3 into 1 plus 4. So it comes down to be 5. Right? So the minimum value of the function is 2 and maximum value of the function is the. So we have only two critical points. One is minus 1 and one is 1, right? At one it is telling it is point of local maximum, and we can, since there is only one local maximum, so we can it is point of local maximum, right? And this point function is attaining the maximum value, and since there is only one local minimum, so we can also call it point of local minimum. And x is equal to 1, function is attaining its minimum, right? So in this class, you understand basic terminology related to the maxima and minima, and how slope is related with the derivative, and then we study the first derivative test and solve the problem, and the local maxima, local minima, maximum value of the function, and minimum value of the function. So, student, that's all for the today class. The next video, we will try to understand what we do in case of point of reflection, how to find the local maxima and local minima, and also we will understand more examples and second derivative test. And then if we understand second derivative test, we need not to calculate this sign. We can directly tell whether the minus one is point of local minima or not. So that's all for today class. Let's see tomorrow.